All right. So in today's lesson, we are going to be talking about constraints and relationships. And we saw this a little bit yesterday. And these are really important because I can set rules for the different columns of my table to enforce what kind of data can go in there. And this is where databases start to offer a lot of advantages over, say, a spreadsheet. So I can make a spreadsheet and I could get really fancy with my spreadsheet. Any of you who ever worked with Excel know that you can do some pretty amazing stuff with spreadsheets. But it starts to get harder if I want to make sure that my Pokemon name has to start with a capital letter, be at least 3 characters long, and not have any, numbers or symbols, right? And so there's all sorts of constraints that we can add to columns. And we'll write a bunch of SQL today and see that in action. Um, the main constraints are going to be a primary key is actually a certain kind of constraint that we'll talk about. Making a value in a column that has to be unique. We'll talk about what a check constraint is, uh, a not null constraint that there has to be a value. And then a foreign key is actually uh, a constraint, but also, in fact, sort of a relationship. And we got a little bit of a preview of this yesterday, but we'll also, in part 2, get into relationships, right? And again, to just use the spreadsheet example, I could make a spreadsheet where I could have a list of Pokemon information and a list of different moves Pokemon can have, and then the list of which Pokemons have which moves. And with the database, we can formally establish these relationships, right? So I can tell my database, so my database program knows that Pikachu up there is connected to the awesome move. And we saw a little bit of that, but we'll see more of that today, and we'll see some more examples. So that's really the agenda for today. We'll build out some examples. Um, we'll also then continue work on the game store that we did yesterday. We'll add some more constraints and some other things here. And I'll be writing SQL code and running it in Postgres using pSQL as we go. I might do a little diagramming with Draw SQL, but today will probably be more writing of code. So I just want to check in to see if folks have any questions about stuff before we dive in. Cool. And I am going to pull up the Postgres docs, which, as I never get tired of saying, are amazing. And if we just search for constraints, we see that Postgres has a whole chapter on constraints, right? And as the Postgres docs say, data types are a way to limit the kind of data that I can store in a table, but often I need more control than what this provides. And the example they give here is a column that's going to contain the price of a product should only have positive values, right? And so this is a great example of a constraint. And here they actually are showing a check constraint. And this is jumping ahead a little bit, but I think it's useful to see, right? Where I could create a product table. I could create a product number or ID that's an integer, a product name that is text or varchar, and then a price. And they're using the numeric number data type. And then with the check constraint, they're saying that this price has to be greater than 0. And the database will not let me enter a value now that's less than 0. If we want to, when we create a constraint, I can also give it a name, which can be useful sometimes with SQL error messages. And we'll talk about that more in a bit as well. And as you can see, these constraints that I was talking about, primary key, unique, check constraint, null, are really sort of the bread and butter and the main things that we're going to use. So let's go ahead and let's start writing some SQL and dive on in and see some examples. So first off, let's actually start with a primary key. And I have here a file constraints, and let me go ahead and make a user table, and we'll give the user an ID, and we'll make this an auto incrementing number, and we'll give it this primary key constraint. And we'll make our user have a username, which will be a varchar. If I want to specify how long, how many characters the username can be, I can do it this way. It can be up to 255 characters. So if I just say varchar, I believe it will set that 255 limit. And then an email. And we'll come back to email. Like, we're going to want to make the email unique, but we'll worry about that later. So now I've got a user table. And in fact, let me go ahead and log into Postgres. And let's make a database. And we'll just call it constraints. And I need a semicolon at the end. And now I see the create database command that tells me that that command successfully ran. And now I'm going to connect to my constraints database. And now I see in pSQL that the command prompt has changed to the name of the database I'm currently connected to. And right now there's really nothing in it. So now I'm going to go ahead and run my constraints SQL file. And this is a relative path. I ran pSQL from my project root directory. From here. So I can do /i / constraints, and I discovered I have a typo. And let's see what my typo is. And my typo is I have a column type or a column name without a column type. And it's a little tricky because the SQL error messages are not always the friendliest. And this is why it's important, I think, to always just be constantly running your code. And I also am used to writing JavaScript where you want to do trailing commas. SQL does not like trailing commas, so that may have been throwing an error as well. And now that SQL runs. And if I do /d, I see a list of these tables. Note that it's created a sequence because I used this serial type on ID. We talked a little bit about sequences yesterday, and this is how Postgres auto increments ID values. And if I describe my users table, we see that we have, and let's get a little more screen real estate here. There we go. We see that we have an ID column. We see its type. We see the username column. We see its type. We see the email column. We see its type. We'll talk about default values in a little bit. You can add default values for things. Note that for ID, it has this next val in a sequence. So this primary key, well, this is actually from the serial type, and this is what adds next val. Note too that my ID column says not null. Now I did not add a not null constraint here, but since the job of a primary key is to uniquely identify a row of data, a primary key by definition is not null. So one of the things that a primary key constraint does is add not null. And in fact, if we look up primary key in the Postgres docs, we see a really nice description of it. It's a column that can be used, or a group of columns. We'll talk about composite primary keys later. And it's a column that can be used as a unique identifier for rows in the table. So all of my primary key values have to be unique and not null. So these two things are effectively the same, where they're creating a product ID and they're saying unique, not null. But instead, I can just say primary key. And let me go ahead and add a little bit of data. And I saw a couple questions. Let me throw a little bit of data in here, and then I'll pause for questions. I'm going to go ahead and I'm going to add my line drop table if exists users so that I can rerun this code more easily. And let's do insert into users. And for an insert statement, first I have to give my column names. And then I give my values. And we're going to do, let's do Alice and Alice at gmail.com. And let's actually put this here. I think this will make it a little shorter and easier to read. And I'm going to go ahead and run my SQL again. And I see not only the create table operation, but an insert, and this one that tells me one row of data was inserted. And if I do select email from users, we see that we have Alice. If I do select ID from users, we see someone's there with an ID of 1, which is Alice. If I want to grab all my columns, and I'm getting all of the users in my users table, we see I've got one row of data, right? And this primary key was auto-generated because I use serial and we have username and email. And let's add just a couple more users just so we have a little bit more data to make it interesting. And we're going to just go through our ABCs and we'll do Alice and Bob and Carol. And I'm going to run my SQL again. And now let's run our select statement again, select star from users, and we can see all three of our users. And I see a couple hands up. Alex, yes, sir.
AJ had his hand up first.
Oh, AJ, yes, sir.
Okay, it's probably a dumb question, but I imagine it's mostly just the key terms. But is there a rule of thumb when we're capitalizing stuff? Like I see ID is blue but not capitalized as an example. That's a key word, I imagine, or
Yeah, that's a great question. So you actually touch on a really good point. The capitalization is just there for us as humans to make this more readable. And you'll see, and you probably noticed like in the Postgres docs, they don't capitalize much. They do capitalize like create table here. So I can lowercase all this stuff and it will run just fine, right? And I still have everyone in my table. Capitalizing is purely for human readability. The convention is the SQL like operations or commands or terms we capitalize. And that's why I capitalize this create table SQL command, but the name of the table I leave lowercase. You know how VS Code decides to sort of make what color for its sort of SQL extension. I don't quite know. I'm not sure why ID is blue here, for instance. That's a great question. Because this is a column name, this is a column name, this is a column name. I wonder, I think the answer is it just feels like ID is a little special and it decided to make it blue. I honestly don't know why. But yeah, that is a great question because if we make this user ID, note that it's not blue. But the convention is honestly what I've seen is the primary key. We normally just name ID because it makes life so much simpler. And so then because this is the type of a column, so this is an SQL statement, we would capitalize that and capitalize that. You don't have to. And here in the Postgres docs, we see actually they don't capitalize those things, but they do capitalize the constraints. So it's a little bit of dealer's choice. I think the easiest starting point is try to capitalize operations like create table, drop table if exists, and your constraints like primary key and so on. But it's really just for human readability. And you guys will know, like, I don't do select star from Users, I do it lowercase. And that's just because it's easier for me to type.
Thank you. I
Yeah,
think
so great question, because I think that because we've seen other things where the naming conventions are stricter or might actually matter.
yeah. Thank you.
Absolutely, 100%. Great question. Alex, yes, sir.
I think I got like two questions. The first one would be for primary key, it's not naturally incrementing, right? You would need serial for that.
That is correct. If
Okay.
I got rid of, let's make this an int,
Mm-hmm.
and let's watch what happens. So first of all, we get this error null value in column ID of relations violates not null constraint. And the problem is my primary key ID, if I look at that table in SQL,
It
let's
doesn't.
look at my users table. So SQL does not stop when it encounters an error, by the way. So when I ran my SQL file, these parts ran just fine. These parts were the parts throwing the error. And the reason SQL does that is because if I'm importing data from like a CSV file with 10,000 users and like one user's name is wrong, we don't want to break the whole import. But it does mean you have to be a little careful with SQL errors because it will keep going. So it created the table just fine, and it made an ID column. Its type is integer. We see this not null constraint. Note that there is no default value, right? Before this was this next val something, 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 something. And that's not there anymore. And it, in fact, did not create a sequence. If I do /d, before we saw not only this user's table, but a sequence for our user's ID. And then the error that I saw, and let's run that command again. This null value in column ID of relation users violates not null, blah, blah, blah from line 10. I'm inserting into users, but I need to have an ID. An ID can't be null, but I'm not passing in that data. So now if I do, ID, username, and I could put in whatever value I want. I'm just going to comment these out for the moment just so they don't throw an error.
So you could have duplicate IDs in this scenario.
That, no,
Oh,
you,
primary
you
key.
cannot.
Primary key doesn't allow that.
Yeah, the primary key will not allow it. It should say when we look at the table description in P-SQL, it really should say there's a unique rule, but
Okay.
I'm 99% sure it won't allow this.
Yeah,
Yep.
it won't.
Duplicate key value violates unique constraint users P key, right? So,
But it won't naturally let it. I guess maybe you could have 10 uh after a 22 ID. It's not, it allows like no order, sort of.
right. And Postgres by itself doesn't enforce ordering. It's the sequence where it's like it just the way the sequence works creates the next one in order. Um, but I could in fact like if I could make a bunch of primary keys and I could delete some stuff and that would screw up the order and Postgres doesn't care.
Got it.
Yeah, great question. Great
Um,
question.
the other one would be, I guess, with these just insert syntax. You wouldn't be able to just do one insert line, like say for number 9, and then lines 10 and 11 would be values, values, and then just keep going down with like the values.
I think that does work actually. I may have jumped the gun here. I think that would do it. Let's change this to 25. Syntax error at or near values. I think maybe does it want me to do it like this? Let's see. Yeah, there we go. That's a good point. I totally forgot about that.
Uh,
Right. And to put this all on one line, right? This would make an awful long one line, so we break it up into two lines for readability. And yeah, that's actually a great point, Alex. Thank you.
Uh,
Because I think this is definitely the better way to do it, right? And to just kind of review this syntax for folks, I say insert into my table name, and then I give the columns that we're going to be providing values for. Then I say values, and then for each individual set of values, I put it in parentheses. And in fact, that's a much better way to do this. And then I need commas after each, set of values and a semicolon at the end.
and then for clarification's sake, say we did not enter an ID, um, say in this insert into users, but we still in the table, we still had ID, serial, primary key. Does the serial naturally add integers or an ID if you have it there? But you
It does.
okay.
So let's run this and see what happens. Yeah, because this is a good point as well. So this works, right? Why does this work? If I look at what tables I've created a users table, and I've created what Postgres calls a sequence. And a sequence is not a table, but it's a way to generate a bunch of numbers in a sequence or a bunch of something in a sequence. And so Postgres actually like has its own basically domain specific language and all these functions and stuff. So the same way I can sort of use a range in Python, or there's other ways for me to like have auto incrementing numbers, I can make a sequence and I can use next val and current val and set val to grab the next thing from that sequence or work with it. We don't need to worry about creating sequences ourselves too much, but under the hood, that's how Postgres auto increments numbers, and that's what Serial uses to generate those primary key IDs. And so what we see happening, and in fact, here we see the increment option, and there's other things here for sequence. If I now look at this users table, note that my ID column type integer, not null constraint, but it has a default value. But that default value isn't hello world or 4 or 5 or 23. That default value is whatever the next value in my sequence is. And so Postgres will start with 1, and then it'll bump the sequence up to 2, and so on and so forth. So Postgres basically inserts for me 1, 2, 3.
And if you have IDs already, it will just build on top of that.
No, we have to do an extra step for that, which I went over at the end of the lesson yesterday, but I'll reshare that code later.
Okay. Thank
Yeah,
you.
just because it's a little magic, so I don't want to get lost in the sauce on it. Yeah. So the key thing here is serial, and that's what sets up the auto incrementing. Yeah, great question. Thank you. And does that help break it down a bit?
Yes, that was perfect. Thank you.
Definitely. Rick, I think you had a question as well.
Don't worry about it. I answer my own question.
Okay, cool. And Cricket, I think did you have a question as well, sir?
So serial is like auto sequence the number of the ID, not
Exactly.
duplicating. Oh,
Yeah,
okay.
exactly. Nice. So the good news is we don't have to worry too much about sequences. And to be honest, I used Postgres and other relational databases a lot in my professional career before joining Code Platoon, and I've never had to set up a sequence in my life. But it is good to know about, and there are some edge cases where it comes up. Um, let's keep talking about constraints. And the primary key is a really important constraint, and we've dug into that one. I think that really naturally leads into unique and not null, because that's sort of what a primary key does for us, right? And so let's talk about the not null constraint for our username. And then we'll talk about the unique constraint for our email. And to kind of hop back up to Postgres constraints, and let's just go check out their docs for the not null constraint. And again, I really recommend having the Postgres docs up because I think their examples are pretty great. Not null is pretty straightforward. It says that a column must not assume a null value. And to give an example of this, like I could go ahead here and let's say I want to give an email and let's do email and username. And we'll do Alice, right? And so the order that I put these in matters. And then we'll do Bob. And then let's do Carol. And I'm not going to give Carol a username. And let's see what happens. This might actually throw an error, but if it does, it will be an easy fix. And indeed, we actually get an error here. Values lists must all be of the same length. Because I put username here, I have to pass it. So let's actually just get rid of that and let's not pass a username for anyone. And that works just fine. And if we look at our users table, we see that these usernames are empty. And in fact, the username is now null, right? And if I did select star from users where username equals null, and I add the semicolon, let's see here, equals, oh, it might have set an empty string here. Let's try where username is null. There we go. So that took me a minute there. We'll talk more about the where clause later. I can use it to filter things. Like I could do where email equals alice@gmail.com. We get Alice. And let's in fact insert into, actually, let's go ahead. Let's maybe alter Alice's email so that she has a value. And in fact, let me do a quick search here. I have to kind of, yeah, this is a little more advanced actually. I don't want to get into update and where, well, we'll talk more about that tomorrow. The main thing I want to point out is that this username column is null right now. It's not an empty string. The value is actually null. And that's okay. It's not great, right? I really want all my users to have a username. I think I want that to be required. I could add a default value. And I think that syntax is correct. We'll find out in a sec when we run it. Yep, and now if I do select star from users, we see that this default value was created for each of these usernames, but that's not really what I want to happen with the username. I really want the username to exist, right? So we're going to say not null. The username cannot be null. And now when I try to do this insert statement, I get an error, and the error says null value violates not null constraint. And if I look at my users table, we see that for the username column, there is this not null constraint, right? So now I have to provide a username. And we'll do Alice, and we'll do Bob, And just for fun, let's actually make Carol's username Bob. And now that works just fine. But what if, something has gone wrong and actually I have two emails that are the same? Well, this is not great, right? And this is where I can use the unique constraint. And let's hop over here to the unique constraint real quick. And as it implies, it will enforce that the data in this column has to be unique, right? And so let's say I decide it's okay if two users have the same username, but I don't want the emails to be the same because that will make it impossible to email different people, and you can't have duplicate email addresses. They don't really exist anyway. So we'll say unique, and in fact, we'll say not null unique because I want the email address to have to exist as well. And now if I run this, we get an error. Let's see here, relation users does not exist. And that's because I added a comma at the end, which is probably one of the easiest typos to make. And now we see a better error. And it says constraint error, duplicate key value violates unique constraint. Now let's take a look at this data. And actually, because these are all in one insert statement, none of these got inserted. If these were three separate insert statements, these first two values would have successfully inserted. So that is one difference between doing like one big insert statement and in individual ones. So now I have to change this email address from Bob to Carol, right? And now I can run my SQL. It works, and we see our users, and we see Carol. Note how email is going to be unique for every user. It's sometimes called like a natural primary key because it can uniquely identify users. It is usually a good idea to actually have a number as a primary key because a user might change their email address. And also, once I get into table relationships, having numbers as the primary key is easier. So best practice is almost always create an ID, int for primary key, even if we have a natural primary key. And I just want to pause and check in and see if folks have any questions thus far. Arnold, yes, sir.
Yeah, sorry, I didn't catch that. You said best practice is to create an ID int for primary key. So not serial when you do the unique.
Oh, so serial actually is integer.
Oh, okay.
I just meant like make a. I was just sort of typing in shorthand. I
Gotcha.
just meant it's to make an ID that's a number, and we probably want it to auto increment, and that we don't want to use this email for our primary key. Because I could, right? I could do email varchar primary key, and actually there's nothing stopping me from doing this. And sometimes you might want to, but most of the time it's going to be way easier to have a column named ID and have it be a number.
Thank you.
Yeah, that's a great point. Okay, awesome. Let's take a look at a check constraint, and then we can take a short break. Oh, was there a question?
I'll ask the question during the break.
Okay, cool. So let me go ahead and let's make another table here. And this is going to be a movies table. And it's going to have an ID. And it's going to be an auto incrementing or serial primary key. We're going to have a movie name, and it'll be a varchar and an age limit. And we'll make this an int. And this is, you know, how old someone has to be allowed to see the movie. And let's do insert into movies, and we'll do, so we need name and age limit, and we'll do values, and let's do, you know, Toy Story. And, you know, you only have to be 5 years old to see Toy Story. But then, you know, to go see Predator, if it ever came back into theaters, you have to be over 18. And if we go ahead and we run this code, let's see here, we have a typo, syntax error, at or near value. And I just need the S in values, I believe, which is why I love to always run my code every 5 minutes. And I just simply forgot my drop table if exists movies. So if we need to modify this table, which we're going to do, it can be easier. And now my code runs. If I examine my database, I see I have 2 tables and this ID sequence for each of my tables. And if I examine my movies table, we see what we've created. And if I look at the data in the movies table, we see our movies. So far so good. But, you know, what I don't want someone to be able to do is Toy Story 2, and you have to be at least negative 50 years old. And for Predator 2, you have to be at least 150 years old. And I just need to replace that semicolon with the comma, and that one as well. And this wouldn't make any sense, right? I don't have data integrity. This data does not now reflect like how I want to design my program and sort of model my universe of moviegoers. And this is where the check constraint comes in. And we saw a preview of this earlier. Let me hop up to it in the Postgres docs. The check constraint is extremely flexible. As you can see, you can use it for numbers, and you would just put the constraints you want in parentheses. If you want to, you can like create different checks with names, which is a little out of scope for what we're going to see now. You can also, let's see if they have an example of, they don't have an example here of a check constraint with text, but we'll see that in a bit. And so just to build a simple check constraint here, what I want is I want to check when inserting data that my age limit is at least 0. And really, let's say like greater than 0. And let's say that the age limit is less than or equal to 18. Right? There's no, once you're 18 years of age, you get to see whatever movie you want. So there's no point in having anything beyond that. And now if I run my code, we get this insertion error. New row for relation movies violates check constraint. Note how it's generated a name for this constraint. If I wanted to, I could come up with my own name, but they use the table name, the column name, and then some information about the check. And so now, you know, if I make Toy Story 2 also 5, and let's make Predator 2 17, just to have a different number in there. it runs just fine, and I can see my movies. Let's see here. I think the one other check I want to show while we're looking at this is how to use check for strings. And I am going to need a little help because we're going to have to see how Postgres handles regex. And pattern matching is a common term for regex. And let's see if this is the page that sort of goes over. I might want a different page here. We'll just use their we'll use the AI help here. So this curly bracket is how regular expression matching is done. So we can use it to compare a value to some sort of regex. And what we're seeing here in these examples is we're comparing the string hello world to see if it contains, capital WORLD, which it does not. And then we can do exclamation point, curly squiggle for does not match. We can do case insensitive. We can get more advanced if we need to do regex match. And I'm actually going to quickly use ChatGPT to help me with this because I'm not a regex wizard. And let's say, give me a simple regex to enforce first letter must be uppercase and no special characters. Now, these days, movies can be anything. But this looks pretty good. So let's grab this and let's try and use this with a check statement for our movie name. So we're going to say check and open and close parentheses. And we're going to say that name matches this regex that I've copied. And I'm going to add a comment saying movie title must start with uppercase letter, no special characters. So let's try and, first of all, let's run this and make sure I didn't do anything silly and break anything. And it looks like I have a syntax error here, probably because I probably need some single quotes around my regex matching, I think. Let's see if this does it. So now we can insert stuff, but now it looks like something with my movie names it doesn't like.
You had it not have numbers. So it's seeing
Oh
the
yeah,
twos.
excellent point. I don't have numbers in here, though. It says failing row contains Toy Story. Let's add in.
Yeah, but it's Story 2. Oh, never mind.
Yeah, let's see if that does it. This may not be what's causing it. Oh, actually, yep, we're still failing the movie name check, which is interesting. So yeah, I think the regex here, I'm gonna actually use ChatGPT to fix this for me. So we wanted to start with an uppercase letter, and only allow letters and numbers. And we'll just say this is Postgres. And I do not recommend using ChatGPT for most things. Regex is by far like my weakest area. Um, so every now and then I think it's not the end of the world, but for learning purposes, it is a little dangerous. So this is a little bit of do what I say and not what I do. So name varchar check, name, and this looks quite similar. It looks like I just screwed up with my 0 or 9 not being included in here. So to say that it has to start with an uppercase letter, and then all the other letters, all the other characters have to be a letter or a number, all the way to the end of the string. And let's see if that works. And we're getting close here. I may just pause on this one, because I think I'm getting lost in the sauce with the regex, and I don't want to spend too much time debugging it. I wonder if the issue here is the space character.
So is check like a SQL if statement or what somewhat?
Sort of. Yeah. So the issue here was the space character. So I can insert these movies. If I have a movie starting with a lowercase letter, it will complain. We see it's failing a check. This points out the downside of having all of this in one insert statement. Because if I did it like this, then some of these would pass and some of these would fail. And in fact, let's watch this happen. And let's do, we have Toy Story. Let's do Predator 2, which will fail, and Toy Story 2, which will succeed. And so note how everything else gets inserted, but this one for Predator 2 with the lowercase p, because my movie title has to start with an uppercase letter, now fails the check. And if I do select star from movies, we see the other three. Right. And in fact, I think I want to add a space in here, if I have that right, so I can add spaces in my movie titles. I'm not sure if I'm doing that regex correctly. I think we did. Yep. We can now have spaces in our movie titles, which is great. And now Predator 2, I want to have an uppercase P. And if I added a dash, this would also fail, right? Because a dash is not allowed. And I'll just add a note here. Fails the age limit regex check. And Alex, you're basically correct. It's like an if statement because it's looking at the value that I'm using. And this is actually failing the movie title, the movie name regex check. When I'm inserting this value, it's looking at this value here. It's saying if this is true, it's a valid value, right? If the name matches this regex, it's a valid value. If my age limit is greater than 0 and less than or equal to 18, it's a valid value and it returns true. So imagine like writing a mini function just to do this comparison check. And it's very much, you probably would use an if statement to do that. Does that help answer your question?
Yep. Thank you.
Yeah, great question. I saw there was another question or two. I just want to look at this code for a sec to see if there's anything else we should hit on before we take questions and take a break. We've covered our insert statement. We've covered primary keys we've covered. We saw not null in other places. And again, we can combine these together. For instance, movie names. I don't think a movie name should be able to be null. And actually, I think movie names should be unique. I suppose you could have different movies with the same name, so I might not want that unique constraint. But I just want to put it here as an example of how I can combine these things to help give me really good data. Right, because now and actually we'll just get rid of that one. Now my database makes sure that I don't accidentally insert two duplicate two duplicate rows of information for the same movie. Right, and we see that it did not insert the duplicate Predator 2. It did not insert the incorrectly named movie title. And AJ, I think you had a question, sir.
The space thing was messing me up, but you solved it by including it in your regex. I just thought it maybe spaces weren't allowed until you cleared that up, so I'm good.
Awesome, good to go. Yeah, that was my bad for not putting it in the regex in the original version. You know, like I've said, this stuff is too complicated for anyone to keep in everything in their head. And for better or for worse, the one thing that is definitely not in my head is regex. That said, my rule has always been when I use whether it's Stack Overflow or ChatGPT to get some regex, I might take like 10 minutes going over that regex line by line to make sure I understand it. And I'll always add a comment like explaining what it is for another programmer. And so again, I think especially as our programs get bigger, you know, if you're looking at guide code or other code, the golden rule is you have to understand what your code does so that you're able to debug it. And that, you know, it might take 20, 30 minutes, but that time is well spent. All right, let's take a break. We've covered a lot of good ground here. We've looked at the primary key constraint, the unique constraint, the check constraint, and the not null constraint. We've seen them in action. In part two, we'll get to relationships. I actually think there is one more thing I want to show, and then we will take a break. And that one more thing is how I can combine the unique constraint in some interesting ways. So let's see how I can combine multiple columns in one single constraint. You don't need to do this often, but every now and then it comes up, and it is a great technique to be aware of. So what I'm going to do is I'm going to make a table for superhero names. So let's rock table if exists, superhero names, and we'll do create table superhero names. And I'm going to do ID serial primary key, the statement we're coming to know and love. My superhero will have a first name, which will be a varchar, and a last name. And let's just say first name has to be less than at least 20 characters. And the last name also 20 characters, just for fun. And so what I want is each superhero full name has to be unique. So for example, Bruce Wayne, right? Or Clark Kent. Or I mean Batman is a one-word name, so I'm going with their alias names. So how can I do this? I can actually use the unique constraint, and I can say unique first name, last name. right? And so what this does is this creates a constraint that enforces that the first and last names have to be unique combinations. And let's see this in action. And let's do insert into superhero names, first name, last name, and we'll do values, and we'll do Bruce Wayne. And let's do Clark Kent. And let's do Bruce Wayne again. And let's do Bruce Campbell, right? The actor. So this one will fail the unique constraint, but this one will pass. Because the unique constraint says this combination of first and last names has to be unique. So fingers crossed, I've written this SQL correctly. Let's go ahead and run it. So we see some errors. We're expecting to see some errors. We know that SQL keeps executing. We see the errors coming from line 54 here, and it says duplicate key violates unique constraint, and they've constructed a really long name here for the constraint. And then we see an insertion. And if I do select star from superhero names, we see Bruce Wayne, Clark Kent, Bruce Campbell, but that duplicate Bruce Wayne was rejected. And if we examine that table and we give ourselves a little more real estate, we see that here under indexes, it's created an index that it's using to keep track of this unique constraint for first name and last name. So you can do this with any constraint. I think this is one of the more common use cases. For instance, you might want username and email, or to make sure a student isn't enrolled in the same class twice. So there's all sorts of situations where this can be useful. So I did want to demonstrate this more advanced application of a constraint. And I just want to pause here and see if folks have questions or stuff that we're curious about. All right. Oh, Tony, yes, sir.
Yeah, so I'm big into like the big picture thing. So like we're rarely actually going to hard code these insert statements, right? This is more just for to display how it works. Like this is mostly going to be run by code, right?
Yeah,
Outside.
that's correct.
Okay.
You will, in fact, when we get to Django, Django will actually generate SQL for us. That said, it is good to see this. It is good to know how to do this because it's so flexible and powerful. And sometimes you just need to stick some names in a database, right? On a practical level, if I had to write a ton of SQL, I would probably have one file that had all of my table creation logic to build the schema and separate files for my insert statements. If stuff was getting really complicated, I might even have each individual table in a separate SQL file, because then it gives me even more control over rebuilding tables and stuff like that. Yeah, great question. Great question. All right, gentlemen, let's take 10 minutes. We've covered a lot of good ground. We've dug deep into constraints. When we come back, we're going to see how to set up relationships between our tables so our users can have profiles and our students can enroll in classes, and our superheroes can have adventures or whatever other tables we come up with, or our game store can have purchases. All right, gentlemen, thank you very much, and I'll see everyone in 10 minutes.